Good morning, students. In this video today, I'll discuss about organic chemistry. In this chapter, you have to study about organic compounds. So first, you have to know what are organic compounds. Organic compounds are the compounds derived from living organisms, derived from plants, animal. Okay, so organic compounds are obtained from living organisms, and all organic compounds contain carbon. And the branch of chemistry dealing with organic compounds is named organic chemistry. Okay, so organic chemistry is the branch of chemistry where you will study about organic compounds, and organic compounds are obtained from living organisms. Example of organic compounds: sugar, starch, protein, acetic acid. All these are organic compounds because these compounds are obtained from living organisms, from plants, from animals. Okay, and they are made up of carbon. The first organic compounds prepared in laboratory by Friedrich Wöhler. The compound is urea. It is the first laboratory prepared organic compound from ammonium cyanate. Okay, Fried Wöhler prepared this compound urea from ammonium cyanate. This is the first laboratory prepared organic compounds. And Colve in 1845, Colve prepared acetic acid, which is also an organic compound, acetic acid. Berthelot synthesized methane gas in 1856. Okay, so these are some example of laboratory prepared organic compounds. So organic I have told already that in all organic compounds carbon must be present. So organic chemistry is essentially the chemistry of carbon compounds, because in all organic compound carbon must be present. So organic chemistry is essentially the chemistry of carbon compounds. So what are organic compounds? I have already told. And what is organic chemistry also? So organic compounds are compounds that obtained from living organisms. And the organic chemistry is defined as the study of organic compounds, that is carbon containing compounds. There are few examples of carbon containing compounds which are not organic compounds. You have to remember the name of these carbon containing compounds. Although carbon is present in this compound, but these are not organic compound, like carbon dioxide, carbon monoxide. Carbon dioxide, carbon monoxide, metallic carbonate like sodium carbonate, potassium carbonate, calcium carbonate, metal cyanide like potassium cyanide, sodium cyanide, metal carbide. Except these carbon containing compounds, all the other containing compounds are organic compounds, except this. That means except oxide of carbon, that is carbon dioxide, carbon monoxide, metallic carbonate like sodium carbonate, potassium carbonate, and metal cyanide, potassium cyanide, sodium cyanide, these and metal carbide. Except these carbon containing compounds, all carbon containing compounds are organic compounds. Sources of organic compounds I have already told: plants, animals, coal, petroleum, wood, fermentation. These are sources of organic compounds. Now see here, difference between organic and inorganic compounds are given. So the difference between presence of carbon. In all organic compound, carbon must be present. So carbon is necessary element in every organic compounds, but in inorganic compounds, carbon is not an essential element in inorganic compounds. And remember that inorganic compounds are obtained from minerals. Okay, these are not obtained from living organisms. Inorganic compounds are obtained from minerals mainly. Okay, so solubility: organic compounds They generally do not dissolve in water. Organic compounds do not dissolve in water generally, but inorganic compounds generally dissolve in water. Solubility in organic solvent. Organic compounds are soluble in organic solvent like alcohol, benzene, chloroform. Organic compounds are soluble in organic solvent, but inorganic compounds do not dissolve in organic solvent. Okay, inorganic compounds dissolve in water but do not dissolve in organic solvent, and organic compounds do not dissolve in water but dissolve in organic solvent. Organic compounds are polar covalently bonded. That's why they have low melting point, boiling point, and they easily decompose on heating. And inorganic compounds are mainly ionic compounds, and they have high melting point, boiling point, and usually do not decompose on heating. Inorganic compounds. Okay, so organic compounds has low boiling point, melting point, and inorganic compounds have high melting point, boiling point. Combustibility. Organic compounds contain carbon, so they are inflammable. They catch fire easily. Organic compounds, because they contain carbon, and inorganic compounds do not burn easily. Bonding in organic compounds, I have already told. In organic compounds, covalent bonds are present. Okay, so organic compounds, they form covalent bond, and inorganic compounds, most of them form ionic bond. Isomerism and conductivity. Organic compounds are non-electrolyte because they are covalently bonded. They are non-electrolyte. They do not produce ions in solution, but inorganic compounds are good electrolytes. Okay, they dissociate into ions in water. Okay, they are conductor of electricity. Inorganic compounds. Organic compounds, they show isomerism, but inorganic compounds do not show isomerism. And color. Organic compounds have characteristic color. Most of inorganic compounds are colorless and odorless. Okay. Reaction, rate of reaction. Rate of organic reaction of organic compounds are slow due to presence of covalent linkage. And inorganic compounds, in inorganic compounds, ionic bonds are present, so the reaction of ionic compounds or inorganic compounds are faster. So these are some difference between organic and inorganic compounds. Now see unique property or unique nature of carbon atoms. Unique nature of carbon atoms. Carbon atoms has two unique nature. One is tetravalency of carbon, that is carbon has total 4 bonds. Okay, tetravalency of carbon. Carbon can form total maximum 4 bonds because it has 4 electron in the valence shell. So tetravalency. Carbon can form 4 covalent bonds. Second important characteristic of carbon is catenation property. That is, catenation means cell formation of cell linkage. Okay, so carbon atom possesses a unique property to link together, that is self-linking, to form very long chains, branch chain ring compounds. And this property of carbon is known as catenation property, that is self-linking property of carbon. And due to this catenation property, carbon can form long chain. So carbon has two unique property. One is tetravalency, that is it can form maximum 4 covalent bonds, and catenation property of carbon, that is self-linking. The property of self-linking of atoms of an element through covalent bond in order to form straight chain, branch chain, and cyclic chain of different size is known as catenation property. The property of self-linking of atom of an element through covalent bond in order to form straight chain, branch chain, and cyclic chain of different sizes is known as catenation property. Due to catenation property, carbon can form this type of straight chain long chain, here you can see, or this type of branch chain, cyclic compound of different sizes. So due to catenation property, I have told that due to catenation property, carbon can form. This is a special type of property of carbon. Due to this property of carbon, due to catenation property, carbon can form straight chain, cyclic chain, or branch chain. Even it can also form single bond, that is double bond, triple bond also. Okay. So here in this figure, it is showing the formation of straight chain, branch chain, and cyclic compounds of carbon, and formation of double bond, triple bond. Okay. So organic chemistry may be defined as the chemistry of hydrocarbon and their derivatives. What are hydrocarbon? Compounds of carbon and hydrogens are known as organic compounds. Compounds of carbon and hydrogen are known as hydrocarbons. Okay, and the organic chemistry is may be defined as the chemistry of hydrocarbon and their derivatives. Okay, now see types of organic compounds. Types of organic compounds. In this table 12.1, you can see types of organic compounds. Organic compounds can be classified as hydrocarbon, alcohol, aldehyde, ketone, carboxylic acid, ether, halide, and these compounds are identified by the presence of certain group. For example, hydrocarbon are three types: alkane, alkene, and alkyne. In alkane, carbon-carbon single bonds are present. In alkene, carbon-carbon double bond must be present. In alkyne, carbon-carbon triple bond must be present. Examples are also given here. You can see in ethane, CH3 single bond CH3. In ethylene or ethene, CH2 double bond CH2. In ethine, CH triple bond CH. Okay, so all these are hydrocarbon made up of only carbon and hydrogen. And hydrocarbon I have told three types: alkane, alkene, and alkyne, based on types of bond present between carbon atoms. Okay, if all bonds are single bond, then it is alkane. If at least one double bond is present in the carbon compound, then the compound is known as alkene. And if triple bond is present, then the compound is alkyne. If OH group is present in the compound, then it is then the compound is known as alcohol. If CHO group is present, then the compound will be aldehyde. If C double bond is present, C double bond O group is present, then compound is ketone. Okay, so based on this group present in the organic compound, organic compounds are different type: hydrocarbon, alcohol, aldehyde, ketone, carboxylic acid, ether, halide. Okay, so in this chapter mainly you have to study about hydrocarbon, that is compounds of carbon and hydrogen. So in this tabular form it is given hydrocarbon are two type: aliphatic and cyclic, or closed chain compounds. Aliphatic are open chain compounds and cyclic or closed chain. Aliphatic compounds are further classified into saturated and unsaturated. Saturated hydrocarbons are also known as alkane, and unsaturated are two types: alkene and alkyne. Okay, so this is the classification of hydrocarbon. So first, saturated hydrocarbon. General formula of saturated hydrocarbon is given. You can see CnH2n plus 2. Saturated hydrocarbons are also known as alkane. In saturated hydrocarbon, all carbon-carbon bonds are single bond. Okay, so in saturated hydrocarbon, all the four valencies of carbons are satisfied by single covalent bond. Okay, in saturated hydrocarbon, all bonds are single covalent bonds. Unsaturated hydrocarbon. In unsaturated hydrocarbon, at least one double bond or triple bond must be present. If double bond present in the unsaturated hydrocarbon, then the unsaturated hydrocarbon will be known as alkene. If triple bond is there, then the compound is alkyne. Okay, so alkene and alkyne both are unsaturated hydrocarbon. Difference between saturated and unsaturated hydrocarbon is given, you can see. Okay, in saturated hydrocarbon, all four valencies of carbon atoms are satisfied by forming single covalent bond. But in unsaturated hydrocarbon, the valency of at least two carbon atoms are not fully satisfied by the hydrogen atom. In saturated hydrocarbon, carbon atoms joined only by a single covalent bond. In unsaturated hydrocarbon, carbon atoms are joined by double covalent bond or triple covalent bond. Saturated hydrocarbon, they are less reactive due to non-availability of electrons in the single covalent bond. And unsaturated hydrocarbon, they are more reactive due to presence of electron in double bond or in triple bond. And therefore unsaturated hydrocarbon undergo addition reaction and saturated hydrocarbon undergo substitution reaction. And here you can see cyclic or closed chain or ring chain compounds of carbon are given. Some compounds like cyclopropane, cyclopentane, cyclohexene, these are cyclic compounds of carbon. Okay, here benzene is also cyclic compound, benzene, toluene, phenol, all these are organic compounds, cyclic organic compounds. Okay, thank you students. In next class I will discuss about alkyl group, homologous series, functional group. Okay, thank you students.